Now that we've got a basic understanding of how this printer works, kind of the nomenclature, the name of all the different parts, let's assemble a cassette to a printer and see what happens. The ribbon needs to be loaded properly. And the proper direction of ribbon loading is the take-up core goes on the opposite side of the hand of the printer. So this is a right-hand printer. The ribbon will go on the right-hand side. Now, because the cassette is assembled backwards, it will technically go on the left-hand side if you were looking at it from the front. Everything is assembled and now we are ready to print. Let's break this printing process down into the most minute detail possible to give you the best understanding of what's actually going on and maybe where some of the errors can come from and what to look for when an error happens. First, when I assembled the cassette to the printer, it started the calibration process. But how did the printer know the cassette was assembled? So this right here is our cassette magnet. Now I'm going to remove this polycarbonate cover from our printhead PCB and show you what lies underneath. And underneath is a sensor that works with that magnet. Now I'm going to take a magnet here and put it right up to that sensor and trick it into starting the calibration process. The calibration process is critical to the function of this printer. After inserting the cassette with the fully loaded ribbon, the printer will initiate the calibration process. This involves the two mandrels that the ribbon and take-up core are loaded onto. They will engage with motor couplings, so they'll spin until they click into place. Once they do that, the print head will move back and forth to make sure there's no obstructions, and your calibration will be complete. This step is critical. It's where we do our first error check. If there are any errors present with the function of the printer, whether that be the movement of the head, the cassette, the tension of the ribbon, this is the step where we'll find that. The next question that might come up is, how does this cassette stay in its position, stay assembled to the printer? And that's done by this goofy looking screw here. We call this the cassette locking screw. Really clever name for it. But there's one thing I want to mention about this. So you can change the engagement of the cassette. Now think of my hand as a latch, okay? When this cassette is assembled, the cassette will be held in place by the latch. We can change the amount of engagement by either unthreading this screw, increasing the length from this wall to this shoulder, from this wall to this shoulder, making it actually stick further away from the printer, or we can increase the engagement by decreasing the length, pulling the cassette closer to the printer. There is a Goldilocks zone, right? You don't want to be too tall because then you'll be too far away from the printer. The magnet will never engage. You'll never get, you'll get cassette open air. Pay attention, right? That might be something you're thinking about. And you can't be too close, because if you're too close, like if you tighten that screw up way too much, it'll never actually latch onto the latch and it can't be held in place. It'll just fall right off. So you got to find that Goldilocks zone. And most of the time that's set for you, especially if you buy a cassette from us, we'll make sure before they go out, they're all tested. After the printer and cassette are fully assembled, we go through the whole calibration process. We are ready to start printing, but we have one small step to get there. And that is to go from offline to online. Now the offline mode is kind of like an idle mode. The printers, you can change some settings, you can pick new jobs, but if that printer gets told to print by a print trigger, or even if you try to manually, you wouldn't be able to do it because he's not ready to be run. He's actually not in position to be run either. You'll notice the head actually goes into position once you make the change from offline to online mode. This is most noticeable in the continuous mode, because what happens there is you want to make sure the print head is always set on the center of the roller, okay? And you can set that in the settings. There's a position for it, but you'll notice when he goes from offline to online, he's going to run to whatever that position is and stay there, because that head's never going to move from there. It's just going to go down when it wants to print. The last thing with the cassette that I want to go into is just how are the parts assembled. All 5 of these, we have the 3 alignment shafts and the 2 mandrels. All 5 of them are held in place by a M6 set screw. So in order to get the post off, you use a 10mm wrench here, an 8mm wrench on this, unthread it, and you can replace it. The mandrels are a little bit more. You need a 2.5mm Allen key to take this friction cone off here. This will allow the end cap to come off. Then you can slide the whole body off, and there's a little wrench flat on the shaft of this. You'll use a 5mm wrench to take that off and replace it. Now, I always recommend everybody gets a spare cassette. And the reason I recommend people have a spare is because these things get dropped by operators from time to time, and they don't like to admit that things have been dropped. So what'll happen is they'll just tell you, oh, we got problems. We'll go over the errors later. We'll go through the flow charts, but what you're gonna see is ribbon break error, ribbon break error, ribbon break error. And it's gonna be because something was dropped and something's not aligning properly. The mandrels can't really click into those motor couplings, and so it's just gonna throw up that error. So have a spare cassette, also know how to change it.